Okay, hello. I thought I'd do another topic. So, multi-stage events and applications of probability, whatever. It's just probability. All right. Let's see. Here it is. First, I wanted to show you this thing. Let me just zoom in a bit, just because I think this concept's really important. So, this is a tree diagram. This would represent flipping a coin and then rolling a die. So notice these are it's called the sample space. These are the possible outcomes. So there's 12 in total. Notice for each of these possibilities, head or tail, there's 6 possibilities for both. That's why you multiply these numbers. Whenever you got multiple events, you multiply the numbers to figure out the total and to figure out the probabilities. So the chance of getting a head and a 5 would be a half chance and a 1 out of 6. Half times 1 out of 6 is 1 out of 12. Or you can just count it. There's only one way to get that out of 12 in total. If you wanted a heads and an even number, there's 2, 4, 6. There's 3. So 3 out of 12 is a quarter. Or you can do, there's a half chance of getting a head and a half of getting a even number. So half times a half is a quarter. Anyway, whatever, just keep that in mind. Here's some other ones. This could just be, okay, yes or no, male or female. Each one branches out. Notice here, so there's 2, then there'll be 4, and then 8. Keep timesing by 2. Okay, this is like, this one they're saying that you can't have a 1 here. Notice there's no 1 here, and there's no 2 here, and there's no 3. So they're saying you can't repeat a digit. That's a different kind of problem. I love these photos. What does that have to do with it? I find it hilarious. There's a couple like that. Oh, it's business people. What's this situation? Okay, again, this one's not being able to repeat, but I find that confusing. So, what are the photos? Oh, that's a good one. He's got an 8 in his password. That guy's using a laptop. Look at them, they look happy and they're doing business. People playing netball. Alright, there's heaps of photos. And that one's a good one as well. Okay, these are the questions I wanted to look at just quickly. Alright, so here we go. I'm going to change the layout. So the chance that only one shows a die, one die shows a 6. That's weird. I don't know why they're emphasizing only one. It's like they're assuming there might be neither. Okay, that one shows a 6 and one doesn't. I'm trying to think. This is actually a little bit tricky for the first question. The chance that the first one shows a 6 is 1 out of 6, but if 2 dice are rolled, 2 dice. Okay, well let's just list it for now. You could get a 6 and a 1, a 6 and a 2, a 6 and a 3, a 6 and a 4, 6 and a 5. You can't get 2 6s, so there's 5 there. You could also get like a 1 and a 6, a 2 and a 6. So basically the same, but these can also happen. They're separate possibilities. So there's actually 5 of each. So I'd say 10 out of 36 in total, because 6 times 6 is 36 if there's 2 dice. And then you simplify that. You can use a calculator. Just half 10 and half 36. 5 out of 18. So C is the answer. Okay, Daniel's deciding on the number of digits. 5 compared to 4. Okay, well let's just do both of them. If he's using 5 digits, now it's an invoice number, so I assume it can start with a 0 or anything. So I would say 10 to the power of 5 for 5 digits. 10 times 10 times 10 times 10 times 10, which is 100,000. It has 5 zeros. Go away. Alright, and then if it's only 4 digits, it'll have only 10,000, 4 zeros. So how many more numbers? I'm pretty sure you just subtract. So 100,000 take away 10,000 is 90,000. So I'm pretty sure B is the answer. Okay, 3. How many different ways? Oh boy, maths. Can they? I don't know why they say in a row. That makes it sound confusing. I'm thinking of rows of letters. But just how many different orders? The letters are all different. So one way to think of it is you've got 5 choices for the first letter, and then you've got 4 choices for the next one, and then 3, then 2, then 1. But this has a name. This is called 5 factorial with an exclamation mark, okay? And it's 120. So just use a calculator. So there's quite a lot. You don't want to list those. There's too many to list. For first and second, okay, no dead heats. So this is easy. There's 20 people that could come first, and then once you pick them, the number 1 spot, there's 19 choices. This is the same as on your calculator, 20p2. C is for when you choose 2 people, but this has an order, 20p2. So I think that's 380. Okay, so C. Best 5 employees. Okay, so out of those 5, first and second, very similar. So it'll be 5p2, but just 5 times 4. 5 choices and then 4 choices again because there's an order. So that's 20 different ways. Okay, Jasmine has 2 packets of jelly babies, 2 orange and 4 red. Okay, what's the chance they're both orange? Well, 2 out of, there's 6 in total, so there's a 1 out of 3 chance of it being orange. And she's taking 1 for each packet, so it doesn't affect each other. So it's just a 1 out of 3 chance times a 1 out of 3 chance. And you should know how to do it. You times the top times the bottom. 1 out of 9. Ta-da! Okay, so B. Alright. Cupboard has 7 white and 4 black mugs. And then it's delicately returned after its color has been carefully noted. It's just, this is a thing in probability. If you take something, it affects the probabilities. If you return it, then it leaves the probabilities the same. That's why they're emphasizing that. Okay, just this part. Oh, gosh. This part. Okay, so the first one, the same color. Okay, so there's a few possibilities. The first one could be white, which is 7 out of 11, because there's 11 in total. And then it's replaced again, and then they pick one again, so it's a bit confusing. So the chance that the next one is also white is 7 out of 11. Okay, so that's 2 whites. For 2 blacks, it could be 4 out of 11, 4 out of 11 times 4 out of 11 again. Now I can do this. This is 49, and that's 16. It's all out of 11 times 11 is 121. So, whoops. No. It's killing me. Okay, so 49 plus 16. Okay, which is 65. That's what I got. So this one, D. Okay. At least 1 6 if a die is thrown twice. Okay, this question is almost the same as the first one. But this is saying that what's the chance that one of them shows a 6 and the other doesn't? And there was only 10 ways, these 10. For this question, at least 1 6. So all of these ones count, but there's also one extra case. Oops, where you get 2 6s. And that's it. Those are all the possibilities. So 5 plus 5 plus 1 is 11. So there are 11 ways to get at least 1 6. There is a shortcut as well, sort of. So 11 out of 36 is the answer for that one. Yeah, the shortcut, the opposite of getting at least 1 6 is getting no 6s. So to get not a 6, you've got a 5 out of 6 chance. And to do that twice in a row, you have to times it. So if you do not a 6, not a 6, that would be, there's a 25 out of 36 chance that you get no 6s. So the opposite of that, if you do 36 take away 25, you get that one, 11 out of 36. Alright? Or just 1 minus that. 1 minus that equals that. Okay. They really should take that word out. Just 100 times. A tail and a head. What? Oh, okay. One of each. How often will you get one of each? Well, let's imagine you've got a tree diagram. You've got heads or tails, and then you've got heads, tails, heads, tails. So there's, I'll just list it here. So there's 4 possibilities: heads, 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 tails, tails, heads, tails, tails. Okay. So notice that there are 2 cases where you get the same, heads and tails. So 2 out of 4 in total. So there's a 50% chance. So it'd be this one, half of the time. It's the same with families. If families have 2 children, half of the time you'd expect a boy and a girl. Okay, whichever order. Only a quarter of the time would you get 2 boys and a quarter of the time 2 girls. That sort of thing. Alright. 2-digit number. Okay, but we can't use the same digit twice. Okay, we choose the tens and then the units. From the tree diagram. I think they want us to draw a tree diagram. But I can just sort of draw it. You've got to start with, hang on. Okay, you could start with a 2, and then the next digit could be a 4, or a 6, or an 8. Okay, you could start with a 4, and then get 42, 46, 48. In fact, I know how many in total. There's 4 digits, so we've got 4 choices, and then another 3 choices for the second digits. 4 times 3 is 12. Should be 12. 1, 2, 3, 4, 5, 6. 62, 64, 68. 82, 84, 86. So, whoops. Maybe I'll make that not an equation. There we go. And just put spaces in. Okay, so those are all the possibilities. So that's the sample space. Okay, 12 different numbers. What's the probability that it starts with a 4? Easy. So how many start with a 4? So there's 3 out of 12 in total. But simplify it. So 3 out of 12 is a quarter. So a 25% chance that it starts with a 4. Ends with an 8. There's 1, 2, 3, 3. So still 3 out of 12. That's the chance of it starting with a 4. That's the chance of it ending with an 8. It's the same. What's the chance of it being the number 62? There's only 1 of that out of 12 in total. So there's a 1 in 12 chance of that one. Okay? That's the answer to D. Sorry, I'm not really labeling it, but hopefully I'm making it clear which part's which. Okay, 4 cards, I guess, of each suit. I put on the table. 1 card is selected at random. What? 1 card's picked at random, and then it's put on the table again, and then another card's taken. So the first time, there's 4 possibilities, and the second time, there's again 4 possibilities. So 4 times 4 is 16. Look, I'm just going to get rid of all this stuff. Whatever, let's keep going. So 4 times 4, so 16 possibilities for question 2. This picture's starting to creep me out, it's just weird. Okay, so 1, 2, 3, 4, 5. How many ways can they stand in a queue? This is the same as, there was another one. 5. Where was it? Not that one. I swear the answer was 120. This one. No, that wasn't it. Did I do it wrong? Maybe it was from another. I'm probably getting jumbled up. But there's just, wait, did I do it here? No, I must have done it another day. Oh, here, why did I do that? So hang on, I want to figure this out. 100,000 take away 90,000. What? That's the only one I can see this. Oh, this one, maths. Okay. There's 5 times 4 times 3 different orders, okay? Just for each letter. So it's actually the same question. It's the same thing. 5 times 4. So the answer is 120, okay? Sorry, I just really wanted to know where it was from. 1, 2, 3, 4, 5, 6. Where's Alex or Alyssa? Where's the A name? Okay, anyway, 6. Okay, they're selected. 2 people are selected, and the order is important. They have positions. So that means it's not C, it's P. So we're going to do 6P2. There's 6 choices, and then there's 5 choices. It's 30. If you do that on your calculator, you'll just get 30. Or you can just ignore that and figure this out. It's up to you. It's the same thing. The chance of selecting Chris then Fran, there's only one way to do that. I would have to pick Chris and then Fran, and that would have to be it. So then if I did that, that's 1 out of 30. Okay, there's only one way, and there's 30 total. Okay, that's it. So is this meant to relate to the picture? 1, 2, 3, 4. So 4 women and 2 guys. Okay. The community. Okay, so if it's 4, it's just 6P4. So 6 choices, and then you've got 5 choices, and then 4, and then 3, which I think is 360. Okay. Alright, let's move on. Okay, ABC are independent events, meaning they don't affect each other, I think. AB, I'm guessing that means A and B. What's the chance that A happens and B happens? For that, you just multiply them, okay? I don't want to spend much on this. You just times them. So a third times a half, so will be a sixth. Okay, you just times them. A third times a half. For this one, you just do a half times 2/5. Oops, what am I doing? Okay, so I'll write it out this time. Half times 2/5 is just 1/5. Okay, if you've got 2/5, half of that will just be 1/5. ABC means times all 3 together. Okay, so I'll just write it. Times them all together. So I've already times here these 2, so I just got to times by a third. So it'll be 1/15. Okay, let's keep going. First and second place. So it's in order. So we're just going to do 14 times 13. Okay, let me practice that in my head. So, I got the wrong number. So I think it's 182. Okay. If first, second, and third. Okay, this is getting boring. First, second, third, and then for the next one, first, second, third, fourth. And keep in mind, by the way, you can also do 14P4 and 14P3, 14P2. These numbers will get quite big, as you can maybe guess. I'm not going to worry about what they are. Just use a calculator. Alright, number 7. Okay, we're selecting a committee of 7. This is without order. So this is where you need to do 10C7 for part A. So 10C7. I can use a calculator. I'm just gonna, does this have factorial? Yep. Okay, over, I'm just calculating it another way. Okay, so, okay, that one happens to be 120. But just use your calculator. Same for this, 11C7 and 12C7, because we're just choosing them. Alright, and those numbers will be bigger. Okay, bag has 10 cards. It's from A to J, without replacement. So this time we're taking them and just keeping them. How many possible selections? So we've got 10 cards, and then once the first one is picked, there's 9 choices, and then 8. 10 times 8, 9 times 8, whatever that is. Okay. What's the chance that D is selected as the first letter? Well, it's only one letter out of 10. There's only a 1 out of 10 chance. Okay, that's the answer. That's the chance of selecting D. The probability of drawing D, there's only one way to possibly get it. You have to get those letters in that order, so 1 out of 720. Chance of that is very small. Okay, this is a bit trickier. What's the chance of getting D with the first letter or with the second letter? Oh boy. Trying to think. These can be tricky. So I already know it's a 1 out of 10 chance that's the first. Oh, okay, actually, I guess it's the same. The chance of it being the second letter is also just 1 out of 10. But are they separate from each other? I guess it is. It can't be the first letter and the second letter. So I think you just add those. So 1 out of 10 plus 1 out of 10 is 2 out of 10. Okay, let me just think if that's right. Chance of the first letter is 1 out of 10. Chance of it being the second letter is separate, also 1 out of 10. You can just add them. Yeah, that actually seems tricky. Simplify it. So there's a 20% chance that it's one of the first 2 letters. Okay, the bag contains 4 cards, BQRS. So they remove 2. Okay, this is easy as well. What's the chance of getting a P? Just a 1 out of 4 for the first card. What's the chance of getting PQ? Well, there's different ways of thinking of it. In total, there's 4, and then once you pick 4, one of the 4, there's 3 left. So 4 times 3 is 12. So there's a 1 in 12 chance of getting that. But another way of thinking of it is there's a 1 in 4 chance of getting a P, and then out of the 3 left, there's a 1 out of 3 chance of getting a Q. But anyway, 1 out of 12. So the chance of getting a P with the first or second, yeah, same thing. I'm confident now it's right. Just think of it as we're picking 2 cards. What's the chance that the P's there? Well, we've got 2 chances out of 4 to get it. 2 out of 4, so a half. 50% chance that the P is one of the 2 cards. Alright, we're getting there, not too many left. A coin is tossed and a die is thrown. Okay, like the example I showed you at the start. Oh, okay, that's exactly what I asked. A head, so we just multiply these probabilities. Chance of getting a head is a half. The chance of getting an even number on a die is a half. 3 out of 6. And that equals a quarter. If you times them. Tossing a tail and then a 1 or a 5. So chance of getting a tail is a half. The chance of getting a 1 or a 5 will be 2 out of 6. Okay, but that's just a third. So if you times a half times a third, you get 6. Okay, so there's a 1 in 6 chance of that happening. Okay, so he's got a 3 out of 4 chance, or 75%. So the chance of him getting no serves, yeah, so the chance of him missing is 1 in 4. The chance of him missing again is you just times it. 1 in 4 times 1 in 4. That'll be 1 in 16. So the chance of getting no serves is only 1 in 16. Most of the time he'll get at least. Okay, so at least 1 is the opposite of that. So 1 take away 16, 15 out of 16. Okay, that's for this one. Okay, box has 4 blue and 9 green without replacement, so we're just taking them out. Okay, 2 blue discs. This is a little bit trickier. The chance of the first one being blue is 4 out of 13, because there's 13 in total. The chance that the next one is blue is 3 out of 12, because there's only 12 left. Okay, and that simplifies to 1 out of 13. I can tell because 3 out of 12 is a quarter, and a quarter of 4 is just 1. Okay, but you can use a calculator. 2 green, it'd be 9 out of 13 for the first one to be green, and then 8 out of 12. And again, I think that simplifies 6 out of 13. Okay, 2 discs, the same color. Well, they've either got to both be blue or both be green. So we can just add those two numbers. Okay, so 1 out of 13 plus 6. Come on, plus 6 out of 13. 7 out of 13. Alright? So 2 discs the same color, either this or this, 2 blue or 2 green, makes 7 out of 13. Now 2 discs of a different color, these relate, okay? They're called complement events. Either you get the same color or different color, one or the other. They're mutually exclusive. So 1 minus 7 out of 13. It's what's left over. Sort of the opposite. Oh no, don't do that. Okay. And that's actually just 6 out of 13. If you do 13 take away 7, you're left with 6. Okay, that's D. Alright, Scott's got 4 queens and 3 jacks. What? He picks 2 cards. Either the first or the second. Okay. He could get... What's the probability of getting a queen? Okay, what's the probability of him getting a queen and then a jack? So he's got a... Let's do it this way. There's a 4 out of 7 chance of him getting a queen. And then a 3 out of 6 chance, because there's only 6 left, that he gets a jack. So that's... Sorry, I'm trying to explain. That's for getting a queen and a jack. Alright? And let's simplify that. 3 out of 6 is a half, so 2 out of 7. That's the chance of a queen and then a jack. Or, let's assume he gets a jack then a queen. So that'd be... what am I doing? I can't see the question. Okay, 3 out of 7, just the opposite. And then times, there's 4 queens out of 6. But I'm pretty sure that's exactly the same. That's the chance of you getting a jack then a queen. Okay, so I hope that sort of makes sense. To get a queen jack, 4 out of 7 times 3 out of 6. Just sequential orders, because there's 4 queens out of 7 in total. And then there's, after that, there's 3 jacks out of the 6 left. So those are the two things. We just need to add those two numbers. So 2 out of 7 plus 2 out of 7, and that's 4 out of 7. That's the chance of getting a queen with one card or the other, but not both. Okay? Okay, chance of having a baby with red hair is 1 in 3, 33%. And the third, oh, that's easy. So if they have 6 children, you just expect a third of that. So 2 should have red hair. So let's just say, I don't know how to write it. Let's just say 6 times a third. Okay, you should know that that's the same as a third. Otherwise, you can do 33 and a third over 100, and that should work. Dog having heartworm. Okay. So 2. 3 out of 8. We just need to times that by 896, which would be 112. I think it's 336 dogs that you'd expect to have heartworm. Last one. Josh plays again with 2 dice. Okay, the financial expectation. I thought they might have more on that, but I'm assuming these are a pretty good balance of types of questions you'll get in the real HSC. Okay, so 2 dice. So that means we're looking at 36 possibilities. Let's just make sure that's clear in our minds. Yeah, actually I might get rid of this stuff now. Let's just get rid of all this stuff. I'm not going to save it anyway. Just thought I might refer to it. Okay, so 36 possibilities. 6 times 6. Now, if you get 2 odd numbers, the chance of that is a half times a half. Chance of getting odd is a half. To get it twice, you have to times, so it's a quarter. So quarter chance, both odd. Okay, so we're going to have a quarter times $30. What else? Okay, an odd and an even. This is a bit like having a boy and a girl or 2 girls. It's the same thing. 1 and a quarter. To get odd and even is 50%, because you could get odd even or even odd. Okay, so that's 50%, so half. Half times $5. But you lose 35 if he has 2 even. So 2 even is a quarter again. Okay, hope that makes sense. So this is for both odd, both even, and 1 of each. That's why it's a quarter and a quarter, but a half in the middle one. Okay. Yeah, I'm not sure how else to explain it. It's like a family. If you have 2 boys, a quarter, 2 girls, a quarter, 1 of each is a half. It's more likely because there's 2 different ways for it to happen. Alright, yep, so just calculate that. Which I think is slightly positive actually. I think it's $1.25. Alright, let's just do it. I'll just check. I should be confident in myself. Okay, $1.25. So on average, he'll get $1.25. So he should really play the game again and again and again. He should spend millions of dollars on it because he'll make money on average. Alright, thanks for watching. I hope that helped. Let me know if you're stuck. Bye.